Hello and welcome to my tutorial channel. Today I'm going to talk about how you can run regression analysis with multiple dependent variables. You can see that I have one independent variable, entrepreneurship education, and I have 13 dependent variables 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I'm going to tell you a little about this. So you can see that here we have the predictor variable, entrepreneurship education, which is the independent variable here. And the outcome variables, that is the dependent variables, that is the same as outcome variables. So we have the constructs of entrepreneurial competencies. So this is a study conducted by Morris et al. In 2013, published by Journal of Small Business Management. In this study, the authors provided 13 competencies that people can gain by participating in entrepreneurship education. So if you go to table 1 of that paper, you can actually download the paper and read. They provided 13 competencies which they identified from their Delphi study. And so these entrepreneurial competencies include opportunity recognition, opportunity assessment, risk mitigation, conveying a compelling vision, tenacity, perseverance, creative problem solving, resource leveraging, guerrilla skills, value creation, maintain focus yet adapt, 11 resilience, 12 self-efficacy, and then the 13th one, which is building and using networks. So if you can actually download this manuscript and then take your time to read this paper. So this study was conducted in a different country, and then if you come to table 2, you will see the summary of the measures. Okay, how they measured them, the items. These are the entrepreneurial competencies they developed from their Delphi study, and these are sources of some of the items that they developed. And so you can see the examples of the items here. You can see this, for example, this one say, I often make novel connections and perceive new relationships between various pieces of information. So that's for opportunity recognition. And so if you look at the reliability in the previous research, that is where they got these items from. You can see in these previous studies. So you see the Chromebox alpha reliability in the previous study where they got the items, where they adapted or adopted the item statements from the measurement scales. So you can see, and some of the places they got. So you can see this was the self-developed by the authors, and so on and so forth. So you can see like this also self-developed by the author. So that's guerrilla skills developed by the author, risk management, mitigation. That is 9 item statements developed by the author, and the same thing here. So what we did in 2021, you can see this paper here published by the International Journal of Management Education in 2021. What we did was to replicate this Morris et al. Study in Nigerian context. So what we did was to find out whether entrepreneurship education can enhance entrepreneurial competencies. These were the hypotheses that we posed. Okay, so we posed that entrepreneurship education will likely positively, because you can see this is H1, 2, 3, 4, 5, 6 to 13, and all of them we posed research hypothesis, not null hypothesis this time, right? These lines here shows you that that we are saying we want to see the direct effect of participation in entrepreneurship education on the individual's opportunity recognition competency. Okay, so that's exactly what we did here. And so this is the SPSS data set for this study. You can see Entrepreneurship Maurice et al. I just want to take you straight to the variables because I've already grouped the Likert scale questionnaire used for data collection into continuous variables. So you may want to check out my video on how you can group Likert scale into continuous variables. Okay. So you will notice that here at this point, it is very difficult. It will be quite difficult for you to run a multiple linear regression here because in this case we have one independent variable with multiple dependent variables. So if you come back to the SPSS, you will see that you can only insert one dependent variable with multiple independent variables. So this is the case of multiple regression analysis. So it's not possible to run this particular type of analysis, a predictive analysis, using multiple linear regression. Then another thing is to see whether you can actually be able to use general linear model like multivariate analysis. Now let us also see if you use the multiple linear models like multivariate analysis. The problem you're going to face here is that you can actually add as many dependent variables as possible inside the dependent variable box, but here you are expected to have fixed factors. So under these fixed factors, you are expected to insert a grouping variable, a variable that maybe like gender, where you have male and female, age, let's say 20 to 30, 31 to 40. And so you can also have your covariates, okay? You cannot be able to conduct this analysis using multivariate. So this leads us to asking the question, how then do we now conduct this analysis? So for you to successfully run this analysis, you will have to do this analysis using a path analysis. So we first of all draw the path. So I will draw the path for entrepreneurship education, and then you can use this to photocopy or duplicate. So I will drop there are 13 variables for the entrepreneurial competencies. So I'm going to produce this into 13 dependent variables. So I will photocopy 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Okay, so the next thing I need to do is to draw the regression lines, the direct effects. I want to see the direct effect of participating in entrepreneurship education and the direct effect of participating in entrepreneurship education on the students' entrepreneurial competencies. So these are the lists, the constructs of entrepreneurial competency. Okay. So I can make it look a little good. All right, so the next thing to do is to draw the error terms. Okay, so remember, if you click 1, 2, 3, all right, so you can position them well. So I click 3 times, 1, 2, 3. You can actually rotate it as you want. All right, so you can actually, as you click, you keep rotating. So but I want it to face the right side, the right side, the right side, the right side. Okay, then I just try to make it look a little good. All right, make them look good. Okay, so this is fine. I will try to resize. So now that I have drawn the model complete, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 competencies, entrepreneurial competencies. There are 13 of them. So you can see 1 to 13. Okay, and they were measured using Likert scale questionnaire. So at this stage, I'll have to save AMOS. So I'm going to save as in any part of my computer. So I can say Maurice et al. Okay. So the next thing is to import the data set from SPSS. So that's why I told you that SPSS is important, because AMOS is an SPSS plugin. Okay. So so I import the data. So you can see this is 1191 against 1191. So that's quite a huge data set. It was collected over a very long period. So we were able to pull out quite a huge number of respondents, students across the country. I need to insert the data. So here, list variables in data set. So the moment you import your data like this and click OK, then the variables will load here on the list variables in data set. So this is entrepreneurship education. So I will insert it here, and then let's head over to this. The next is opportunity recognition. The next is opportunity recognition. So this is opportunity recognition. Drop it. Opportunity assessment. Drop it. The next one is risk mitigation. Vision. Risk mitigation. This is mitigation. The next one is vision. Vision here. Drop vision. So let's head to the next one. Tenacity, perseverance, problem solving. Tenacity. Next, problem solving. Next, drop problem solving. Let's head over there again. The next one is problems of resource leveraging, gorilla skill. Head over to resource. This is resource. The next one is gorilla skill. Then let's head over back to check the next one. Value, adapt. Get back to value, insert value. Value creation, adaptability. The next one is resilience, self-efficacy, and network. So we get back here, resilience, self-efficacy, and lastly, network. Okay, brilliant. So I'll save AMOS. Okay, so I need to make my drawing look good. So the next thing I will do is I will resize. Okay, the next thing is, now that I have named these variables, I also want to name these. If you want, you can actually double click here and name the actual variable, okay, which is entrepreneurial. Okay, entrepreneurship education. Entrepreneurship education. So once you do that, so you see it will replace here. So now that I've named all the variables, the independent variable and the dependent variables here, 1 to 13, the next thing is to name my unobserved variables. So I'm going to name unobserved variables. So so these are the error terms or disturbances, right? If you do not name these in AMOS will not run. So you must have to name them. Okay, so you can have so many. There are some plugins that can actually help you to do some of this, and so you need to get them. The next thing is to resize my. I will have to resize the observed variables so they'll be able to look good. All right. Let me chip this a little. Let me chip this a little. Shift this a little. Okay. I think one of the things I might have to do is to resize them. Okay. Then we want to change the shape to reduce them when they are too bogus. So you can see now they're looking good. Then I save AMOS. So at this point, I need to instruct AMOS the type of analysis I want to run. So I can actually move a little bit, right? And then draw this back. Now remember that if you select all, if you click here, AMOS will select all of them. If you click here, now when you do not, if you click only one, if you select all of them, any action you take will affect all of them. But if you select only one, you can see this. If I drag, only this will change. You see, only this, not all of them. You can check out some of my videos on the use of AMOS. You'll be able to learn how to draw. Okay, so the next thing I want to do now is to instruct AMOS on the type of analysis I want. So this is the output. So I want to see the standardized estimates. Okay, and probably I want to also run a bootstrap, perform bootstrap, and I want it to be done at 95% confidence. So this is bias corrected confidence intervals at 95%. The next thing is I will now click to calculate estimates to run. So we pray AMOS runs. So AMOS begin to run, and thank God it runs. Good. So once AMOS runs, you will see that here, okay, view the output path diagram will become alive. Here you have the unstandardized estimates, and here you have the standardized estimates. So let us open the standardized estimates so you can see these are the analysis, these are the outputs of the regression, the path analysis output. Okay, and if you click the unstandardized, so you're going to see all other outputs, but here the focus is on the standardized coefficients. Now at the standardized coefficient, so you can see these are the direct effects. Okay, the relationship between the effect of entrepreneurship education on opportunity recognition. So you can see so this means that as entrepreneurship education increases, the students opportunity recognition competency or skills increases by 0.31, and so on and so forth. So let us look at the view test. So we go to view test, and so we head over to the estimates. So you can see the estimates. This is the standardized regression, and this is the bootstrap. So let me zoom in so you'll be able to see it clearly. So this is the standardized regression weights, and because I performed bootstrap confidence, so I want to use that. If you do not want to use so this is the unstandardized. Okay, this is the unstandardized, which makes use of critical ratios and so on and so forth, but the emphasis here is on the standardized regression weights. In AMOS, the analysis goes the arrow points backwards, but you can actually use a clean estimate plugin to get the directions correctly. But you can see that the effect of entrepreneurship education on each of the entrepreneurial competencies developed by Maurice et al. Each of these entrepreneurial competencies here, as shown in our own study here, So you can see the results, the output here. So you see, this is the influence of entrepreneurship, the effect of entrepreneurship education on opportunity recognition here. The estimate is 0.31 and is statistically significant. That is P is 0.001, significant alpha level. And entrepreneurship education on opportunity assessment has the regression beta weight estimate of 0.19 and is statistically significant. And this is the upper and lower confidence interval. So here, this is an analysis that also helps to confirm that the relationship between this variable and this variable is positive. You can see that here, 0 did not fall between the null. All right. So you can see the effect of entrepreneurship education on risk mitigation. You can see that the estimate is very low. The regression weight is very, very low, 0.002 estimate. And then you can see that it's not statistically significant because you can see the p-value is above 0.05 significant alpha level. And then you can also see the confirmation that the relationship between entrepreneurship education and risk mitigation is not statistically significant because you can see 0 falls between the null. You can see you have the negative 0.051, and then at the upper level of confidence interval is positive 0.063. So which confirms that we do not have evidence of this relationship, the effect of entrepreneurship education on risk mitigation within the population of this study, not in the whole world. Please, we need to be careful about generalizing our findings. Then you can also see that the entrepreneurship education on vision was not statistically significant. Here, the same thing on tenacity is positive but not statistically significant. But we have entrepreneurship education on problem solving is quite huge, 0.214. The regression size, beta weight effect weight, and is statistically significant. And the same thing here, the effect of entrepreneurship education on self-efficacy, which is 0.257. If you approximate, so you're going to have 0.256. And you can see the confidence intervals here, which proves, which confirms the positive results and is statistically significant. Then another one is that the students also, the analysis shows that as entrepreneurship education increases, students' ability to build networks of people who may want to become business owners in the future also increased by 0.065. And this is statistically significant, but at less than 0.05 alpha significant level. You can see the p-value is 0.03, which is lower than 0.05. So let me show you this result. Let me use a clean estimate to produce this result in a much cleaner way. So what I will do is that I'll use this plugin, Clean Estimates, by James Gaskin. So you can visit StartWiki to check out the plugin and then be able to install it into your AMOS. So we wait a little for AMOS to produce the result of the clean estimate, and then it opens. So you can see this is a merged regression weight. Okay, so you see the predictor, which is the entrepreneurship education. You can see please disregard this R here. So this is the entrepreneurship education. So the outcome variables, we have the opportunity recognition and the 13 entrepreneurial competencies. So let's head back to you can see the triple asterisk here. It says triple asterisk P is less than 0.001. You can see the two asterisks. Okay, unfortunately, there's no two asterisks. Then you have the one asterisk, which is 0.05 alpha level. Okay, so let's head over to the results. So this is the result. If you go down to the paper, you're going to see the result here. So this is the result of this study. It was conducted in 2021. So let us check the effect of entrepreneurship on opportunity recognition. And so we see the result of the AMOS. So you see entrepreneurship education opportunity recognition, and is 0.31. And let's see, this is 0.31, the standard error. Then the confidence interval, if you go to AMOS view test, let me also show you the confidence interval here. So you can see the confidence interval is 0.24 and 0.37. So let us see. So you can see 0.24, 0.37, and is statistically significant. P-value less than 0.001. So same thing with an opportunity assessment. So you can see the bold line showed statistically significant direct effects, while the dotted line here, you see the dotted line showed non-significant results. Okay, so you can see the bold effect here. You see this is a problem solving. So let us head over here and confirm that problem solving, the effect of entrepreneurship education on problem solving is 0.214. Okay, so come to the paper, 0.21. Okay, if you because the 4 we are reporting on, we reported on 2 decimal places. Okay, so same thing to entrepreneurship self-efficacy, entrepreneurship education on self-efficacy. So you can see that 0.26. So let us see the output. Self-efficacy 0.257. So if you approximate this, that is 0.26. All right. Yeah. So and then the last one, which is building and using networks. So this is the results. Entrepreneurship education on entrepreneurs on networks is 0.065. So you approximate to 0.067. So this is what we have here. This is what we have here. This is the evidence of the statistically significant effect, because 0 did not fall between the null, and so this is the result here, less than 0.05, and then you can also confirm that here. And that is also what we did here. So for you to see the SE here means standard errors. Okay, the standard error values. If you want to see the standard error values, so you see this is the standard errors. So you go to the bootstraps, standard error for the bootstrap. So this is where I got the standard errors that we reported in the study. Okay, so this is how you can run your analysis if you have multiple dependent variables like this. The beauty of using AMOS is that AMOS can actually allow you to run series of analysis in one structural model simultaneously. Okay, but this is one thing that SPSS may likely not be able to do. All right. So in this case, supposing I have another variable now, so you can see I will simply insert the variable here. For example, I can open here, insert the variable, and then covariate the errors, and then maybe something like this, and then still run another analysis entirely. All right. So thank you so much, and I hope you learned something from this demonstration today. Let's see how you were able to treat multiple dependent variables with one or two independent variables. And let's see how you were able to do that, how you were able to manage that. If you experienced some difficulties or challenges, what were there, and then we'll be able to address them in next tutorial. Thank you so much for watching.